Hi, elementary operation on a matrix or elementary transformations. See here, if you take two square matrix, one is A, another is B. If you get in product equal to some identity matrix, this is equal to B again A, commutative. So AB equal to BA, commutative property, that is equal to IN, identity matrix. Then this B is called inverse of A. Again, if A is inverse of B, then B is inverse of A. This is the definition of inverse. This point you have to remember. Now one theorem says that any square matrix A into adjoint of that matrix A equal to determine A into IN equal to adjoint of A into A. That we are taking commutative property of product. So A into adjoint of A equal to determinant of A into IN equal to adjoint of A into A. This is one theorem. From this we can see that when you are taking A inverse, we know that A inverse means in all 1 by A only. That is why you are getting A, B equal to IN, 1 by A. That A cancel, you will get it I. So here A is taking this side. So therefore we will say that A inverse, that is 1 by A, equal to adjoint of A divided by determinant of A. So this is property. But we know that one division by 0 is not defined. So determinant A should be not equal to 0. That means non-singular. So A should be non-singular matrix. Then only we can find out the inverse of a matrix using this relation A inverse equal to adjoint of divided by determinant of A. Now these are the two definitions you have studied. Now we want to find out how to find out inverse of a matrix using elementary operations. So elementary row operations. So here there are three row operations. One is any row can be interchanged with another row. Any row can be interchanged with another row. Second property is any row you can multiply with some constant Ri equal to K into Ri. So third property is to any row you can add a scalar multiples of another row. Ri and Rj. So any two rows we can interchange. Any row can be multiplied with any constant. Third property, to any row, Ri here, we are saying with that Ri, we can add a scalar multiplier of another row. So these are your three elementary row operations. See here, using this elementary operation, you want to find the inverse of a matrix. Finding the inverse. You can do it any one of these row transformations. Three row transformation using how to find out the inverse of a matrix. So in row transformation, if you want to find out the inverse, always take A equal to IA. A equal to IA. Now see here, this is your given matrix, this is your identity matrix. So we are doing some row operations on this equation and changing this I to one matrix such that A into this matrix is equal to this identity matrix. So your target is to change this one as a identity matrix. So if you able to change this one as identity matrix, we can say that this is the inverse of this matrix. So always try to take A equal to IA, this equation. Now we will see that one question and we will start the procedure. So here A is coming. Here they have given matrix 2 minus 6, 1 minus 2. So we have to write it A equal to IA. So 2 minus 6, 1 minus 2 equal to I means 1, 0, 0, 1 identity matrix, then A. We are writing A itself. We are not writing the elements there. Now this A given matrix into this matrix, if you able to make this one as I, we can say this matrix is inverse of this. This is our target. So first one is, we have to see that here, this is your first row, first column. You see, when you are writing a matrix, you will get A11, first row, first column, A12, A13. This is your rows, second one is your first column, second column, third column. Then A21, A22, A23, second row. Again, third row, A31, A32, A33. This is here 3 by 3 matrix. Order is 3. So this is your diagonal elements. A11, A22, A33. So this will call as principal diagonal. Principal diagonal. Now this element we have to make is what identity matrix is 1. So this should not make as a 0. So first step we have to remember that this one A11, A22 and A33 should be not equal to 0. If it is coming 0 means immediately you can take any row interchange and change into non-zero. Second property, this you have made first one A11 you have to make as 1. Change A11 as 1 because we know identity matrix is 1 first will come. Then A21, A31 should be 0. A21 and A31. This has to change into 0. This is the second step. Third step is you have to make here A22 as 1. This 1, this both 0. Then A22 as 1. After making this 1, we have to go A32 and A33. A32 as 0. A32 equal to 0. Fourth one, A33 is 1. Now first we have made this one, this both 0, then this one, this is 0, then this one. Now these three elements is left over. So A23, A3, A13, A12. All this you have to make as 0. Now if you want to remember this easy way, see this picture if you can remember. First this movement. Then here you have to move 1, then here it is coming 0, then here 1, then is you are going here, both 0, then this also 0. So from here you are starting with 1, then this both is 0, then is 1, then this 0, 1, then it is 0, 0, 0. This picture you remember, this is your order. Always. Now see here. So here it is what? 2 minus 2. There is no problem, it's now. So first you want to make this one as 1. So here it is 1, here it is 2. So I can take as first row equal to first row minus 2 times, sorry, R1 minus R2. 2 minus 1 is 1. So we will get it what? That values you write it here. R1 equal to R1 minus R2. 2 minus 1, 1. Minus 6 minus plus. So minus 4. Then this we write as same. No change. Now see here again. 1 minus 0, 1. Then 0 minus 1, minus 1, 0, 1. Okay. Next I told below we have to make a 0. So here you have to make 0. So R2 equal to R2 minus R1. So we'll get it 1 minus 4. 1 minus 1 0. Minus 2 minus plus 4. That is plus 2. So R2 only changing. R1 we can write directly. Now R2 minus 1. 0 minus 1. So 1 minus 1 plus 1, 2. This operation. Now second is this element. So 1, then 0, then we have to make 1. So here it is 2 is coming. So this 2 we have to make as 1. So immediately we can take as what? 2 we have to make, divide by 2. So R2 equal to R2 by 2. See that 1 minus 4. 0, 1, divided by 2. So 1 minus 1, minus 1 by 2, 1. Okay. Now this here, this has to make is what now? 0. So R1 equal to R1 plus, so minus 4 plus 4 times R2. See, 1 plus 4 times 0, 1, minus 4 plus 4 times 1, that is 0. Then this is 1, 0, 1, no change. Now here you have to change again. 1 R1 plus 4 times R2. So 1 plus 4 times minus 1 by 2. This is minus 1 minus 2 minus 1. Then again minus 1 plus 4. Minus 1 plus 4 is 3. This is not changing. because only R1 is we are changing into A. So you see that you got it identity matrix. So this is your inverse matrix. -1 by 2, 3, 1. So we can immediately write the answer as inverse of this matrix is -1, 3, -1 by 2. Now see, for checking this one, you have to do that. This is your principal diagonal. So you interchange the element in the principal diagonal, -2, 2. I have interchanged. This other diagonal element, we directly changing the sign, 6, -1. This is your adjoint of this matrix. Now adjoint of A divided by determinant A is inverse. So immediately you can see determinant of A is what? -4 minus -6. -4 plus 6, that is 2. So 1 divided by 2. So if you take this 2 is inside, we'll get it what? -2 by 2 -1, 6 by 2 3, -1 by 2, 2 by 2 1. See, this is what we got it. See, -1, 3 minus half 1. So inverse is we got using elementary transformations, and for checking you can use this method, change the principal diagonal. So here 2 minus 2 changing, -2 will come here, 2 will come, interchange the elements, and other diagonal you change the sign only, -6 become +6, 1 become -1. So that is your inverse of the matrix. So this both way you got it, same thing. Now we will see one 3 by 3 matrix. So here A equal to again IA. This always you have to write like this only, no change in the row transformation. So A means your elements 0, 1, 2, 1, 2, 3, 3, 1, 1. I means 1, 0, 0, 0, 1, 0, 0, 0, 1 into A. Now we see here diagonal A11 is 0, A22 is 2, A33 1. So here 0, I told first you have to try to remove this. So I am changing this one, this row I am keeping here, this row keeping here. So R1 is changing with R2, interchange, first property. So we'll get it 1, 2, 3, 0, 1, 2, 3, 1, 1 equal to, here will come what? 0, 1, 0, 1, 0, 0, 0, 0, 1 into A. Now you got it first one. So our picture is like this, you have to move. We have told already like this, then like this, come back, go here, then go up like this. So first here is 1, then 0, already you got it. Next you have to make this 3 as 0. For that R3 equal to R3 minus 3 times R1. See, 3 times R1, 3 into minus 0. So you will get it what? 1, 2, 3, 0, 1, 2. This is 3 minus 3, 0. 1 minus 6 minus 5. 1 minus 9 minus 8. Again 0, 1, 0, 1, 0, 0. R3 we have to change 0 minus 0, minus, so minus 3. 1 minus 3 times, that is 3. 1 minus, so 1 only. See, careful element. One element is wrong means your inverse will get changed. Now again you got it this. Here already we got it 1. So immediately next step is see from here, 1 you made. So here you have to make 0. So here you have to get 0. So minus 5 plus 5 times R2. So R3 equal to R3 plus minus 5 plus 5 times R2. See. 1, 2, 3, 0, 1, 2. 0 plus this is 0, minus 5 plus 5 times this 0, then minus 8 plus 5 times 2, 10, minus 8 plus 10, 2. 0, 1, 0, 1, 0, 0. Now this has to change. Now 0 plus 5 times this, so 5. Minus 3 plus 5 times 0, minus 3 only. 1 plus 5 times 0, 1 only. This over. Now this is what we have to make this as 2 as 1. This element. We have reached here 0, now this is 1. So divide R3 equal to R3 by 2. 1, 2, 3, 0, 1, 2, 0, 0, 1 equal to, see, 0, 1, 0, 1, 0, 0, this divided by 2, 5 by 2, minus 3 by 2, 1 by 2. Now this has to come 0, this also has to come 0, this also has to come 0. So R3 equal to R3 minus, R1 equal to R1 minus 3 times R3. R1 equal to R1 minus 3 times R3. Then R2 equal to, I can change here also, R2 minus 2 times R3. So here become what element? R1 we have to change. R1 is R1 minus 3 times R3. So 1 minus 3, so 1 only. 2 minus 3 times 2 only. 3 minus 3 times 1. So that is 0. That was your target. Now again R2 equal to R2 minus 2 R3. This is 0, no problem. 1 minus 0, 0, 1. Then 2 minus 2 times 1. So that is 0. Then 0, 0, 1. 0, 0, 1 equal to. This has to change. So R1 minus 3 times 5 by 2. Now 15 by 2. So minus 15 by 2. Then 1 minus 3 times R3. So minus 9 by 2 plus 9 by 2. So 11 by 2. Then 0 minus 3 by 2, minus 3 by 2. Now R2 means R2 minus 2 R3. So 1 minus 5 by 2. 2 times 5 by 2. 2 cancel, 1 minus 5, minus 4. Then 0 minus 2 cancel, plus 3. Then 0 minus 2 cancel, 1 minus 1. So here is no change. So 5 by 2, 3 by minus 3 by 2 and 1 by 2. Then is coming here only. So this equal to A into A. Now this term we have to make 0. So R1 equal to, next operation, R1 equal to R1 minus 2 times R2. See here, 1 minus 0, that is 1, 2 minus 2 times 1, 0, 0, 0. Other both did not change, 0, no change. So you got it identity here. Now right side you see. This minus 15 by 2 minus 2 times R2. So 2 times R2, that is minus 4. So minus 15 by 2 plus 8. So 8 into 2, 16. 16 minus 5, 1 by 2. So this is 1 by 2. First. Then 11 by 2 minus 6. So 11 minus 12 minus. So minus 1 by 2. Then minus 3 by 2 minus 2 times R2. So plus 2. So 4 minus 3, 1 by 2. So other term is not changed. Minus 4, 3 minus 4. 5 by 2 minus 3 by 2, 1 by 2. So therefore, here inverse equal to, see left side we got it already identity matrix. So this is here inverse. So 1 by 2 minus 1 by 2, 1 by 2 minus 4, 3 minus 1, 5 by 2 minus 3 by 2, 1 by 2. So this is for doing this question. You have to remember only one thing. You have to go this way, 1, 0, 0, then again 1, 1, 0, 1, 1, 0, 0, 0. So 1, then make it change to 0, then 1, 0, then 1, 0, 0, then 0. So there will not be any problem for finding the inverse using row transformation. You remember 1A equal to IA, then this picture. You will get it 6 marks.